For today's math lesson, our topic is linear relationships analyzing linear math stories. Our essential question for this lesson is, what keywords in a math story help us to build data tables to translate into graphs and equations? So, if you would please take a moment to copy the topic and essential question in your header, along with today's date, set up your question column and your note column, and resume the video when you're ready to begin. We're going to start today talking about some vocabulary. So slope and starting value is hopefully starting to feel comfortable in your vocabulary usage as we analyze linear relationships. And slope is our m value in the y equals mx plus b equation. It tells us how fast something is changing and whether it's increasing or decreasing. And so you can see here in this chart, and yes, I do want you to copy this into your notes, these are all words and phrases that in a math story will oftentimes clue you in to a slope value, that they're talking about the slope of that linear pattern or how it's changing. Rate of change is the most common. Anytime they use rate, it might be growth rate or again, that key word really is rate, but oftentimes we'll see it as a rate of change. And things like it increases by or decreases by. So if it's increasing, they're cluing you into a positive slope. If it says decreasing, they're cluing you into a negative slope. If it grows, right, again, that's a key word that this is a positive relationship, and so any numbers that come along with how much it grows is going to be cluing you into the slope. And same with shrinks. So shrinks being the opposite of grows would clue you into a negative slope relationship and how much, so you'd want to be looking around these words to find numbers that go along with that would tell you exactly how much it's changing by. So as you read or write your own math stories about linear relationships, you want to use and look for these words to clue you in for slope. As for the starting value or the b value on our y equals mx plus b equation, they will use words like starts with, the initial value, phi, figure 0. We've been doing a lot with tile patterns. So the b value, these are again just a few keywords. There are more, but these are the ones I really want you to hone in on. So we'll clue you into that if you're making a data table or you're doing your graph, that is going to be your b value. So let's go ahead and apply and look for some of these words in a couple of examples of math stories. Alright, so here's our first example. It's Max's tile pattern. Max has created a tile pattern that started with 7 tiles and grew by 3 tiles for each new figure. So the first thing that I want you to do is read through that math story or that description of Max's tile pattern and see if you can find any of our vocabulary words from our table that might clue you in on how we could start building our table. Alright, maybe you noticed the same thing I did. I highlighted here in green, and I'll continue to do that in this example. So I saw right here it said starts with or started in the past tense. So it started with 7 tiles. It grew by 3 tiles. So already when I'm reading this and I'm looking for those words, I'm trying to imagine or picture in my mind what that looks like. So I know that if it starts with 7 tiles, okay, it's got 7. I don't know the arrangement, but I know that it's growing by or adding 3 new tiles each time. So, this must be a positive linear relationship because it's increasing, and it specifically increases by 3 tiles. Some of you might feel comfortable to start jumping into writing the equation or something like that, but I'm going to start with the table and start to build a table that models this. So if I know that it starts with 7 tiles, well, that's going to be, and it's up here in our chart too, but starting value is always when x is 0, so figure 0 must have 7 tiles. And if it increases by 3 tiles, or it grows by 3 tiles for each new figure, well, I already have the figures here, so it grows one more. Well, 7 plus 3 is 10, and if I add 3 more to that, figure 2 would have 13. And how many does figure 3 have? Well, if you said 16, I agree with you. So there we were able to identify, just from this brief description of this tile pattern, what the starting value was and what the slope, or how much it's increasing the rate of change value is. So from here we really have a few choices. We could go ahead and fill in our information here to write our equation, or we could start graphing. Again, anytime you're working with these models, you want to be able to start translating between any of the three views as fluently as well, so you can really go any which direction. It begins to be whatever you're most comfortable with. So what I'd like you though to do is go ahead and we're going to plot these points on the graph, and then we'll end with the equation. Okay, how'd you do? So what I've done here to build my graph is I have figure number on the x-axis, number of tiles on the y-axis. It matches how I have it set up in the table, and I plotted these points 0, 7, 1, 10, 2, 13 to create the graph representation of Max's tile pattern. And the other important thing is, after I graphed those points, right, now we've drawn a line from our starting value through each of the points using a straight edge or a ruler, going all the way through, because what we want to be able to do is start to make other predictions and say, well, oh, look at here, it looks like there's another point on the graph, so I know that figure 4 must have 19 tiles, and that would fit the pattern, and I could put another point there. So that is why it's really important to, when you're plotting points on the graph, to then use a straight edge or your ruler and extend that line all the way through the graph so that you can continue to use it to make predictions. So the last step that we need to do is to write our equation. What we want to be able to do though is to be able to prove the link between all of these. So what I'd like you to show me on the table and on the graph is, how would you find the slope? So on the table, where do you see the change in y and the change in x, and what is that value? Where do you see the change in y and the change in x on the graph? And where do you find the b value in both of these representations? Because if all three of these representations are going to represent Max's pattern, then we want to be able to see how they all connect and how they all show each of this information. So go ahead and see if you can figure out how to do that. You might be able to refer back to some previous lessons, and we'll check back in just a few moments. So how'd you do? So if you're trying to connect your table to your graph to your equation and show how all of it relates, which you're going to want to be doing in your projects or anytime you're trying to analyze a pattern, then showing how you see the change in y in your table and the change in x in your table, where you see that change in y and that change in x in your graph to show how you're going to find your slope, and then doing the same for your b value. And there's different ways to do that. You can see how I've done mine, so you can model your work after this, of course. And so from this we see that our change in y is of course 3, it's increasing by 3 tiles, and our change in x is 1 because it's increasing by 3 tiles for every new figure. And 3 over 1 as our slope fraction can reduce, and so 3 over 1 reduces to having an m value of just 3. Oops, let's put an equal sign in there. And so our slope is 3 because it grew by 3 tiles. It increased by 3 tiles, and then this is a key part right here for each new figure, and so that might be a good thing to underline, or because each new figure says, oh, this is a ratio, it's 3 tiles for each new figure, 3 over 1, because each stands for 1. And then our starting value, our b value, well, we know that that's where it crosses the y-axis on our graph. We know that's when that point is 0, 7, so our b value comes from the value when x is 0, what is y? So our b value is, of course, 7, and the last thing to do is to plug these values into our equation. So now, from this written description of Max's tile pattern, we were able to identify how it started, how it's changing, so the starting value being our B value, how it's changing being our M value. We were able to create a table and graph those points, and then show from that table and that graph how do we find the M value, how do we find the B value, and put it all together in an equation. What I'd like us to do is do one more example where you do the work and then we check back and see how it compares. So let's go ahead and get ready to start our second example. Alright, here's our second example. It's Lily's monthly book subscription. Lily, an avid reader, has decided to subscribe to a monthly book club. The book club charges an initial fee of $30 to join and costs an additional $5 each month for shipping. So what I'd like you to do is, just like we did in our first description, go ahead and see if you can identify the key words in this math story to find that will tell us about what Lily had to pay to start out, and then how much Lily has to continue to pay each to continue the subscription. So go ahead and pause the video if you need to, and we'll go ahead and highlight that or underline it, mark it somehow, and see where we can go from there. How'd you do? Well, if you realize that the $30 initial fee was how much it starts out with for Lily, for them, and then how much it continues each month, this being how much it changes for Lily's subscription, then I would agree with you. And so what I'd like to see you do now is go ahead and complete the table. Alright, how is it looking? So if the initial fee that they had to pay was $30 and it costs an additional $5 each month for the shipping, we built our table. At 0 months, they just paid the $30 initial fee, and then each additional month they have to pay $5 more for the shipping and to keep their account active. So we would fill in that here. And then I just took these points, 0, 30, and plotted them on the graph. And now we can see, even on this graph, how nice it is to have that line extending out, because we could continue to make our predictions and say, oh, well, it looks like at month 10 it's going to cost Lily a total overall of $80 to have kept this book subscription going. So how do you find the slope, change in y, and change in x in the table? How do you find it in the graph? How do you find the b value and see that connection to the table and the graph, so we can put it all together into our equation? Alright, how's it coming? So hopefully by now you have labeled your table with the change in y and the change in x, so we can start to see how we can find the slope value, the m, from our table, and you've labeled it in your graph. Same with the starting value. So you might notice here in the table I have that change in y is that it's increasing by $5 each month, so x is increasing by 1. But over here on my graph, I have that it goes up 10 over 2. And that's because we've talked a lot about making sure on a graph that we always use points that are on the lattice, or lattice points, so they're on the grid lines. And so while I know what those values are, I could have shown that and shown that it goes up 5 over 1. But I chose to use these lattice points, 0, 30, and 2, 40, and I can show that it goes up by 10, because from 30 to 40 is 10 using the scale on the axis, and on the x-axis each grid line is worth 1, so over 2. So I just wrote a little note here that my slope was 10 over 2, and I'm showing that that simplifies or is equal to 5 over 1, so I can show that it matches what's in my table. And then we can just go ahead and plug these values in, and then the last step is, of course, to write it in our equation. So hopefully what you're seeing through these examples is not only how to find that information from find our starting values, our slope values from a written description of a linear pattern, but you're also showing how to plug that into tables, represent it as a table and a graph and an equation. But we also want to start to show the connection. So how is the slope shown in the table? How is the slope shown in the graph? How is that related to the values we put in here? And so as we're proving how we can represent a linear pattern and translate between all of these views and representations of that pattern, it's important that you also show that you're able to make the connections between each representation. So that's going to conclude our video lesson today on how to analyze linear math stories. Please make sure that your notes are complete, and of course, go ahead and fill in your summary answering our essential question from the beginning of the video.